All right, today 5.3, solving by factoring. Okay, our objectives are to solve quadratic equations using the zero product property, okay, which we see right here. We're going to write a quadratic equation given its solutions. So we're given the solutions, we're going to write the equation, and we're going to solve some real-world applications involving quadratic equations. All right, first of all, a quadratic equation is any equation whose highest degree term, okay, is a squared term. It is in the form of ax squared plus bx plus c equals 0. That's like our standard form of that, okay? But its highest degree term is a squared term, right? That's the 2 is the highest degree term. If the trinomial can be factored, then it can be solved using the zero product property. That's cool. So if it can be factored, then it can be solved using the zero product property. And again, it says our standard form is this ax squared plus bx plus c equals 0 is standard form. All right, so notice our zero product property. It says if PQ equals 0, then P equals 0 or Q equals 0. Okay, because PQ is P times Q. So the only way to equal 0 is for one of those numbers to equal 0. Which you're probably like, how is that helpful? But we're going to show you. All right, so it says solve, example 1, solve x squared plus 2x minus 24 equals 0. The first thing we're going to do is we're going to factor it. Okay, do you remember how to factor the trinomial? Okay, we don't have an a term, right? So we just take the c term and we try to find the product of that sums to be a positive 2. Okay, so if I think we've got negative 24, so I could have negative 6 plus 4, that equals negative 2. If I had a positive 6 plus negative 4, that would equal a positive 2. So these are my factors. So remember, I have two different terms. So I'm going to have x plus 6 times the quantity x minus 4 to factor that. All right, now the thing is, I need to include this equals 0 part, right? We didn't have that last time, so I need to say, okay, well, this equals 0. Now, step 2 says set each factor equal to 0. So I'm going to say, all right, well, what if x plus 6 equals 0? And what if x minus 4 equals 0? So I'm going to set each of those factors equal to 0. So this is an or statement because I'm going to solve, right? When we're trying to find the solution, we're not trying to find a single solution. We're finding the solutions, in this case, to a quadratic. What are all the possibilities? So we need to check when is it x plus 6 is equal to 0 is one possibility. Another one is when x minus 4 is equal to 0. That's another possibility. All right, and so then here we know, well, we would subtract 6, so x would be equal to negative 6. Here we would add 4 to both sides, so x would be equal to a positive 4. Those are my solutions. Like I solved it, those are my solutions. Then if I want to check, okay, we could put this in and check it. Okay, so we would check each of these. So we could check when it was negative 6. So we're going to plug those back into our original equation here. So we'd have negative 6 squared plus 2 times negative 6 minus 24 should equal 0. Okay, so negative 6 squared is 36 plus 2 times negative 6 is negative 12 minus 24 should equal 0. 36 plus negative 12 is 24. 24 minus 24 is 0. So that one checks out. We can plug in 4. So we would have 4 squared plus 2 times 4 minus 24 should equal 0. 4 squared is 16 plus 2 times 4 is 8, minus 24 should equal 0. 16 plus 8 is 24. 24 minus 24 is 0. So 0 equals 0 checks out as well. So our solutions here are x equals -6 and x equals 4. Or we should say or, actually. Okay. Okay. Now if I move on down here, I've got solving quadratic equations by factoring. Okay, so step 1, we're going to write the equation in standard form. We always want that ax squared plus bx plus c equals 0. Step 2 is to factor the polynomial. We kind of did this on the previous one. 3 is apply the zero product property, right? That's to set each factor that contains a variable equal to 0. And then step 4 is solve the resulting equations. So the only thing missing on example 1 was writing it in standard form because we already had it in standard form, which is implying that example 2 and 3, they're not in its standard form. And they're not, right? Like minus 11x is over here. So we're going to add 11x to both sides. Remember, we want it in standard form, so we're going to write this as 3x squared plus 11x plus 6 equals 0. Okay, now we do have an a term and a b term, or sorry, a c term. So 3 times 6 is 18. So we're looking at factors of 18 that equal 11. All right, well, I know I've got 9 and 2 right away, right? They just pop out. So I'm going to have 3x squared plus, I'm going to rewrite this plus 11x as plus 9x plus 2x plus 6 equals 0. I put my 9 first. I kind of talked about this in the notes before, but I put my 9 first because 3 and 9 are, common. It'd be easier to factor out if I put them in that order. Okay, so then we're going to group these two together. I'm going to factor out a 3x here. So 3x squared divided by 3x is x, plus 9x divided by 3x is 3. Here I can factor out a positive 2. So 2x divided by 2 is going to leave me with x, plus 6 divided by 2 is 3. Go ahead and put equals 0. I got that common binomial term. That's what I'm always looking for when I do that step. Okay, so I got that. So I'm going to use that as one of my terms, x plus 3. And then I have the 3x plus 2 left over. And I'm running out of room. Okay, the next step is to do what? Perfect, is to set each of these equal to 0. Okay, so I'm going to have x plus 3 is equal to 0, or 3x plus 2 is equal to 0, which is going to get me here. I would subtract 3 and get x equals -3 for one option. Subtract 2 on both sides. So then I have 3x equals -2. Divide by 3. So we get x is equal to -2/3 for my other solution. So my solutions are -3 right here and -2/3. Awesome. Okay, let's look at B. Let's look at B then. Okay, again, not in standard form. So I need to subtract my 8x. Right, so then I'd have 6x squared minus 8x equals 0. Okay. So it's more in standard form. I don't have a C term. That's okay. I don't have to have the C necessarily. The other thing here that I can think about is 6 and 8, right? We talked about always factoring out the greatest common factor first. I could go ahead and divide this by 2. And let's see here. I could divide my whole equation by 2. 6x squared divided by 2 is going to give me 3x squared. Minus 8x divided by 2 is going to give me minus 4x. 0 divided by 2 is 0. That makes it easier to do. And then now I'm just going to factor this binomial because all I have is a binomial. So what do 3x squared and minus 4x have in common? An x. So 3x squared divided by x is 3x. Negative 4x divided by x is going to give me negative 4. Okay, so my two terms, right, it's two terms with a variable. So I'm going to have x is equal to 0. Sweet, that one's done. And 3x minus 4 is equal to 0. Okay, is my other factor. So add 4 to both sides. So 3x is equal to 4. Divide by 3. And my solution is x equals 4/3. So here my solutions are 0 and 4/3. All right. Okay, next up we have to find a quadratic equation. Okay, so now we're finding the quadratic equation. So we're given the solutions. We're going to reverse the steps. Okay, so we're going to write each solution as a linear equation. So we're going to write the solution as ax plus b equals 0. Then we're going to use the multiplication property of equality to form a quadratic equation. And then we're going to FOIL. Okay, so let's jump in. Example 4. Write a standard form quadratic equation whose solutions are -1/2 and 3. Okay, so let's start out with just having, we've got x, because it's a solution, equals -1/2 and x equals 3. That's what this is telling me, right? My solutions, that means x equals. Okay, so we want to write this in a linear equation form. Okay, so ax plus b equals 0. Well, the way that we can do this is, let's separate this out. This is -1 divided by 2. Okay, so maybe we could say, all right, well, this is divided by 2. So we're going to multiply both sides by 2. So then we end up with 2x equals -1. All right, well, now we want this to be ax plus b equals 0. We need this to be 0, so we're going to add 1 to both sides. And then we'll end up with 2x plus 1 equals 0. So this is that first part. Okay, we've got it now as a linear equation. Right there. On our x equals 3, okay, we can do some work here too. I'm just doing that first part for both of them, right? Because we want this side, the right side, to be 0. So to get rid of 3, we're going to subtract it on both sides. So now we've got x minus 3 equals 0. All right, we've got it in its linear equation form. Now we're going to use the multiplication property of equality to form a quadratic, which means we're going to take these two equations here, because they're both equal to 0. It's like using substitution, and we're going to combine them into one and say, all right, well, the quantity 2x plus 1 times the quantity x minus 3 has to equal 0, because they're both equal to 0, right? This one's equal to 0, this one's equal to 0. If I multiply them together, they're still equal 2, 0. And then I FOIL. So my first 2x times x is 2x squared. I'm going to erase this and move it down so I can show my arrows a little better. So I've got 2x squared. So first, outside, 1 times negative 3. Hold on. First, outside. That's not what I wanted. Sorry, got ahead of myself. Outside is 2x times negative 3 is good, negative 6x. Inside, 1 times x is good, positive x. And the last, 1 times negative 3 is perfect, negative 3 equals 0. Remember, we want to combine our like terms. So we're going to have 2x squared, negative 6x plus x. It's going to give me a negative 5x minus 3 equals 0. This is my quadratic, and it's in standard form. The key is up here in this work, though, right, is in writing it in a linear equation form, getting the right side to equal 0. Okay, and especially this one here, like this step, looking at negative 1/2 as negative 1 divided by 2 is very, very helpful instead of just multiplying by 2 over 1. All right, so many equations with a degree higher than 2 can also be solved using the zero product property. So we're not just limited to those. Many of the others can, not all of them, but many. All right, so let's look at example 5 in this idea. So we have solve 5x cubed plus 3x squared equals 14x. Okay, so we're going to start off the same way. We don't want, where we always want the right side to be a 0. So we're going to subtract 14x from both sides. Okay, and then so we get 5x cubed plus 3x squared minus 14x equals 0. All right, then we have talked about factor, the GCF first. So 5, 3, and negative 14 don't have anything in common. However, they all have an x, right? We have x cubed, x squared, and an x. So we can factor out x, which would leave us with 5x squared plus 3x minus 14 equals 0. And now suddenly we have a quadratic. Okay, its highest degree is now 2. So we could still have that quadratic. All right, so now we have our quadratic. We have an a term and we have a c term. So 5, I'm going to grab my calculator. 5 times negative 14. Oh, if it would work. Sorry, have to clear my memory. So 5 times negative 14 is negative 70. All right, and we need to find factors of negative 70 that equal a positive 3. So it's going to be near the middle, right? When we want a small number, it's going to be a factor near the middle, like 2 factors that are close together. Ooh, 7 and 10, right? 7 and 10. But we need negative 70. So we could do negative 7 and positive 10 or 7 and negative 10. Which one gets me a positive 3 when I add them together? Yeah, right, this one, the negative 7 and positive 10. Okay, so now I've got x. I'm going to rewrite this middle term with my factors times the quantity. So we've got 5x squared plus 10x, because 5 and 10 go nicely together. I know I'm going to group them later. Minus 7x minus 14 equals 0. And again, 7 and 14 group nicely together. All right, to do my next step, remember I group my first 2 terms together and my last 2 terms together. So this x is just hanging out here, right? We've already factored it, so it's just out there. Now I've got 5x squared and 10x. I can factor out a 5x. 5x squared divided by 5x is x. 10x divided by 5x is 2. So we have x plus 2. And then negative 7x and negative 14. I'm going to factor out a negative 7. That'll leave me with x. Negative 14 divided by negative 7 is a positive 2. All right, so now I've got x, right, is my one term. My common binomial is the x plus 2. And then what's left over? 5x minus 7 is my other term. All equals 0. All right, and then I'm solving with the zero product property. So I'm going to take each chunk and set it equal to 0. So I've got x equals 0, x plus 2 equals 0, and 5x minus 7 equals 0. So to go back to x plus 2, we're going to subtract 2. So x equals negative 2 as a solution. 5x minus 7 equals 0. We're going to add 7 to both sides. 5x equals 7. Divide by 5. X equals 7/5. So we have 3 solutions here for this one. Our solutions are 0, negative 2, and 7/5. All right, I'm going to clear this so we can look at our word problem. Okay, so an engineer, sorry, my light's getting in the way. An engineer must increase the area of a launch pad by 75 feet squared. What distance can be added to both the length and the width of a 10-foot by 12-foot pad to meet this requirement? Okay, so we've got this picture, right? This is our current launch pad. It's 10 foot by 12 foot. And we want to increase the area by 75 feet. So increase the launch pad by 75 feet squared. What distance can be added to both the length and the width? That's huge, right? That's why we have an x here, adding it to the length, and an x here to add it to the width. Okay. So if we think about this, this picture is really helpful. What is our length here? Good. It's 12 plus x. My board kind of glitched. All right, so what's my width here? Good. My width equals 10 plus x. Awesome. So we want to increase the area of the launch pad by 75 feet. That's great. We know the length and the width. And what are we finding here, right? We're talking about area. Well, what's the formula of area? Area equals the length times the width, right? Okay, awesome. We have the length measurement. We don't have a number. We have the width measurement. We don't have a number. But we also, they didn't give us anything much about the area, but we do know it. Okay, because we know this is a 10 by 12, which makes this area how big? Good, this area is 120. And we want to increase by 75 feet. So this area up here that we're adding is 75, which means what does our area equal? Or what will it equal in the end? It's going to equal the 120 plus the 75, which is 195 feet squared. I wouldn't have to put that on there because we're working, but you know. That is helpful because now that we know our area and we actually have a measurement, we can write a formula because we know that our length, let's change color here, this quantity 12 plus x times our width 10 plus x is going to equal our area, which is 195. Sweet. That's awesome. Okay, so we need to do some FOILing. So our first numbers, 12 times 10, 120. Our outside, 12 times x, and we have positive 12x. Our inside is a positive 10x, and our last is a positive x squared equals 195. All right, combine our like terms. We've got 120 plus 22x plus x squared equals 195. Okay. This is not quite in the form that we want, right? One, this is not in descending order, it's ascending. So we need to change the order. But this is also not 0 over here. So I'll make this into 2 steps so we can see it. So first, let's change this. We're going to flip them around and say x squared plus 22x plus 120 equals 195. Then we need to make this 0. So we're going to subtract 195 from both sides. And I'm going to come up here to start over. So I'm going to have x squared, or not start over, but to continue, plus 22x, and then 120 minus 195 is negative 75 equals 0. All right. Good news. We do not have an a term, so we're just looking at our negative 75, factors of negative 75 that equal 22. So 25, right, times 3. Let's do a positive 25 and a negative 3, because when I add those, I'd get a positive 22. Okay, so since I don't have this term, remember I just get to say, well, x plus 25 times the quantity x minus 3 equals 0. Right, because I don't have an a term, I just put an x at the beginning of each of those. I'm going to apply that 0 product property, set each of these equal to 0. X plus 25 could equal 0. Whoops. I got carried away with my dividing line here. X plus 25 equals 0, and x minus 3 could equal 0. So if we subtract 25, x could equal negative 25 is one solution. Here we add 3. So x equals a positive 3 is our other solution. Now, this is a real-world problem, real-world application. So we have to think this through on this. Okay, it says, what distance can be added to both the length and the width of the 10 by 12 foot pad to meet this requirement? Can we add a distance of negative 25? No, right? We cannot actually add this. A distance cannot be negative. So this one is out. This is not a possibility, right? Distance cannot be negative. So yeah, in like the theoretical world, we could do that, but we're dealing with the real world application. So negative 25 is not an option. The only one that is a solution is 3. We can add 3 feet to both the length and the width of this launch pad, and we would gain 75 square feet of area. Okay, so it should end up being a 13 by 15 foot launch pad. Okay, awesome stuff right there. Okay, I will see you all tomorrow. Have a great day.